If you want.
No. Do I have to talk like this?
Pick up the mic.
Were you here last time? I'm sorry.
That's okay.
I don't know what to do now.
I wasn't unexcited.
No, actually, it was good.
I think I was great last time, so I don't know. Last time was more like this. So you want to hack a pacemaker? I was so hoarse the next day, I didn't know what to do with myself. Although I'm getting there now. So, okay, so you want to hack a pacemaker. I'm Todd, less yelling. I was going to do the intro in Spanish, but I didn't want to freak out Chris. So he kept having an episode. My name is Todd Brasel. So I'm a principal consultant. I work for a company called NYSTEC, which is one of the best kept secrets in the capital region. It's so secret, you know, we don't even know where it is. So we have multiple locations. We do a lot of consulting for state government. So we do things like we work with the good guys at LEAD. We do risk assessments, blah, blah, blah. This is basically where I am in my career right now. So I'm that guy who can kind of explain some computer science concepts. I've been doing development for about 20 years, but I've also been doing testing and other aspects of it, do a lot of project management, and I'm almost that guy at the bottom. So one of the people I work with, every time I get riled up on something, he brings out this meme. It's like, oh man, you only got clothes. I'm like, yeah, I know. So we have something called Ask an Old Person. So usually I have the young people gather around and I say, hey, it's Ask an Old Person time, so I will explain cassette tapes or I'll explain a mainframe or how these things go together. So how it came on this topic was a bunch of old people and I were sitting around in Ponderosa and we were waiting for, to bring out the fresh chicken. And actually, no, I was working on my master's degree. And I do martial arts. And my sparring partner came to me and he said, well, I just want you to know I've had a heart attack. He'd been gone for a few weeks. He came back and said, I've had a heart attack. Oh my God, you've had a heart attack. Well, that means you've got to stop doing martial arts. I mean, I'm going to have to find another sparring partner. He goes, no, I'm good. I've got this pacemaker, and it keeps my heart functioning normally. And if my heart ever stops, it'll defibrillate and start my heart back up again. And I thought, wow, that's really reassuring. But he also owns his own business. And I thought, well, you're going to have to retire now because you have to avoid the stress of working. And he said, no. My doctor says I can continue with my normal life, and he encourages me to exercise. I have this pacemaker. And then it kind of got into a topic of, well, how does this thing work and what is it doing? I mean, it's obviously monitoring your health, and it's downloading some data to something, and that somehow gets to your doctor. And that got me onto this topic. And I have a bigger presentation which talks about medical devices in general, but I'll spare you that one. So I'll also try to spare you my coughing and sniffling. So the weather's really getting to me. So just as a level set, we're talking here about legal activities only. I want to try to explain some red team approaches and provide some blue team tactics and strategy. You can think of it that way. For you folks who've heard all this before, feel free to just Google, check Facebook, whatever old people do. And in terms of agenda, so we're going to cover some legal aspects. Not old people, I'm sorry. I labeled you, I didn't mean to do that. Legal aspects, devices, talk about who these people are, because that's kind of important to know, give you some context around these things. Talk a bit about the equipment, I'll go into a case study, and towards the end we'll talk about attacks. There have been no known attacks that I know of, no known attacks in the wild on these types of devices. All been in the laboratory, all proofs of concept, so just something to keep in mind. Also, it's a little self-serving because it's a personal area of interest for me. I don't have a pacemaker, I don't have a medical device, but I do have friends who have them. Medicine is also something I'm interested in, so it's kind of this interesting juxtaposition of the human-machine interface and technology. So I really want to hack these things. So if you are interested, I know a guy, maybe we can set something up. Seriously, I do know a guy. And he actually has a lab, and he has funding. He's just looking for some devices. So why hack medical devices? So there are really three main ideas here. So And I'm going to say the term PMDs when I'm talking about our personal medical devices. So PMDs are things like pacemakers. They can be insulin pumps. Someone mentioned fitness trackers earlier. So these are things that collect sensitive data about the wearer, and they use that information to affect treatment on the patient. So there's a lot of sensitive data involved. These devices have vulnerabilities, as all devices do. We'll talk about that in a bit. And there's also an increasing presence. So the use of these devices is growing a lot, and it's kind of a stealthy growth. So the reason why it's a stealthy growth is because the use of the device itself is something that's also can be protected information. Talk about the legal side of things. So my colleague, Michelle Warner, who's an attorney, who specializes in privacy, she and I work together a lot. We've done some other presentations. She helped me put a section together just on what is required to legally hack a PMD. So, and with the disclaimer that this does not constitute legal advice, and I'm not a lawyer, so please speak with legal counsel if you plan to hack your devices. Whoops, jumped ahead. The use of PMDs, their data, and the research into PMDs itself is regulated by the federal government. So, it's like you've been here before. So, hey, wait, I think I know somebody back there. You're Jeff, right? Yeah, okay. Aren't you supposed to be on vacation? Or is that next week?
That happens next week.
Okay, all right. I pay attention. So, anyway, so researchers have to follow really strict rules. They have to carry out research in a very controlled environment, and they have to make sure that they're performing research only for specific purposes as outlined by law, especially if you're doing something that involves, anytime you're working in any field that requires working on devices that interface with humans or doing any kind of human experimentation, even if you're just creating a survey. In some cases, you need to run that by some type of supervisory board. Something to keep in mind. So in terms of legal forces, one thing just to remember here is that there are two agencies, there are two acts, and there's a number of regulations. So medical devices actually fall under the umbrella of the Food and Drug Administration, FDA. And they have provided guidance for medical device cybersecurity since 2003. I'm sorry, since the 60s, but they did draft cybersecurity legislation in 2003. You can see a lot of that is available actually through NIST, and you can look that up. So the FTC, the Federal Trade Commission, also provides some regulation around this. The Digital Millennium Copyright Act right there, DMCA, if you're not familiar with that, that protects medical devices and actually makes it illegal in most cases to circumvent copyright protections on the device. Because these are proprietary devices with closed source software, they're copyrighted, so if you try to circumvent the protections, you're actually violating the DMCA. The Computer Fraud and Abuse Act, which is this piece right there. Computer Fraud and Abuse Act provides prohibits accessing a computer without authorization or going beyond the existing level of authorization you have. So there's two things that would actually prevent you from doing this legally. And this actually was a barrier for a long time. So 21 CFR 803 right here, that's the medical device reporting regulation, contains mandatory requirements for manufacturers and importers, and I'm sorry. Sorry, the voice is going. To report certain device-related adverse events and product problems with the FDA. So basically, 21 CFR requires device manufacturers to report issues. So there is an exemption that was created a few years ago to the DMCA, which allows researchers to be able to do research legally on these devices if they perform them in a legal manner. You can look it up. So if you're going to do this, you're going to have to get legal counsel anyway, and your attorney would be able to advise you how to actually go about doing the research. So enough about the legal stuff, Todd. Let's get on to the good stuff. So what do we talk about when we talk about pacemakers? So personal medical devices like pacemakers, so this is what I'm talking about. They're electronic devices. They can be divided into two broad categories. If you think about it, so there's implanted ones that actually go in your body, and there's wearable devices that go outside. There are many types of devices, but I'm going to focus on pacemakers right here. And this is going to dig into this. Is anybody eating right now? Just out of curiosity before I get started? Okay. All right, Joe, you're fine. I'm not worried about you. Okay, so where do they go? Where do they go? Well, here's a schematic location of where these devices generally land. And these, again, I'm talking about pacemakers. Generally on that side of the body. So implantable devices, they're really designed to be housed inside a patient's body. And they're going to be there for an extended period of time. And they're not really intended to be taken out. So a patient will have to undergo surgery to have the device implanted. And they'll have to undergo periodic surgery to maintain the device and to replace batteries. Usually battery replacement is every 5 to 7 years. There are different types of devices. So there are actual pacemakers, which maintain heart rhythm, cardiac resynchronization therapy devices, which synchronize the heart chambers. I have to read this, I haven't got this memorized quite yet. Implantable cardioverter defibrillators, which is a very common device, and that actually monitors heart rhythm, and that can act as a pacemaker or defibrillator if necessary. That's what my sparring partner has. There are implantable cardiac monitors. There are things such as left ventricular assist devices, which actually are implanted in the heart, and it consists of a pump that helps to improve blood flow through the heart. So there's a bunch of different devices that have, and we started with the simple pacemaker in the late 60s, and as time has gone on, there are more and more therapies that these are being used for. We're seeing more and more of them used among a younger population as well, and I'll talk about that in a second. All pacemakers talk to some kind of base unit, and this is an example of a home monitoring system. This base unit remains in the patient's home. It connects wirelessly to the implant, and it uploads data. So usually what happens is the patient's at home and they go to bed at night. The base unit connects to the pacemaker, downloads information, and then uploads that to the cloud. A base unit can also be a cell phone. So that's something to keep in mind when you're thinking about how to hack these devices, cell phone connection. This is what a typical unit looks like. So they have, again, there's many, many different functions, but they all follow the same form factor. So there's a control unit, which is this piece right here. There's the head, and then there are the leads. So you can combine different heads and different leads to accomplish different purposes with the same unit. There's a lot of flexibility here. This particular image shows an implantable cardioverter defibrillator. And just to give you a sense of size, so this scale up here is in centimeters, but if you think about it, reach in your pocket, get out some change, pull out 3/4, put them side by side, that's what you have right there. It's a very small item. Okay, so here's an X-ray image of a control unit. This is actually taken from a training manual for radiologic technologists, so they know what they're looking for. Gives you an idea of what's inside these things. Okay, so there's the leads, there's the connectors to the leads, so that's the head unit. You can see that there's a battery, there's some circuitry, there's a capacitor. So there's a battery and a capacitor, and they take up most of the unit. This thing is really designed to deliver electric shocks. That's what it's for. There's a little bit of logic there as well. We'll get to that in a second, but that's really what it looks like on the inside. And then in the context of the patient, so you can see on the left side of the body, you've got the can with the header, the battery and the capacitor, and then there's 3 leads that lead off of that, and then these connect to this large mass right here, which is your heart. So just a little basic review. Blood comes in here, gets pumped out to the lungs, comes back from the lungs, goes down in here to this, and then down to the right ventricle and gets pumped out to the body. So these are the leads for the right atrium, these are the coil for the right ventricle. I actually don't know what this device is for, but it gives you a pretty typical deployment. And then you'll notice that there are some other leads out here. They leave leads in your body sometimes just because you might need them for something else later on. So they're not abandoned. what it just says. So you've got this is what the device looks like, and then there it is in the body. So. And then this picture shows what it looks like from the outside. So this is a typical patient, and if he or she pulls their shirt aside, you can actually see this. You can see the device right there, and there's the scar from the implantation. So, with my sparring partner, we have a label on the gi that goes right there, and so it just happens to fall there. So that's a no-go zone. We just don't hit him there. So we can flip him and do everything else, but we can't hit him there. It's really bizarre. So, okay. So wrapping up, there's a common design. So there's a multi-segmented design here. They're designed for long-term use before maintenance. Wireless communication is built in, and just talking about the computing power, I want to talk about that for a second. So the people that program these things, they compare the computing power of a pacemaker or a PMD to a power plant or to an aircraft avionics system. So these things are designed to interact on the fly with what the patient's doing and to deliver different types of therapies to the patient and to maintain the patient's health and also collect data about what the patient's doing. So there's a lot of computing power in that little package. Okay. So who uses PMDs? Just briefly. The numbers are really difficult to determine because a lot of this information is protected information. But there are some estimates that place over 6 million people in the US using personal medical devices. One trend is that they're being used more and more frequently, and I mentioned this before. So in 1966, when pacemakers were first approved for Medicare reimbursement, the American College of Cardiology approved treatment for 56 conditions. And then by 2008, there are 88 different conditions that can be treated by the use of a pacemaker. 16% of implanted cardiac devices are actually used by people under the age of 65, like my friend. About 3 million Americans have had a pacemaker in 2009, and the most common users of PMDs in general are cardiac patients and, of course, diabetics because they have insulin pumps and other types of monitoring devices. I just find this really fascinating. Every time I go to speak, there's usually someone in the room who has a device. So that also means that they're also in the workforce. So here's an example of a patient. Does anybody, don't answer this. Does anybody know who this is, just out of curiosity? So this is Marie Moe. She's a security researcher. I thought she was well known. And she has an implanted pacemaker. So she's researching the security threats that exist for these devices. She didn't really know about them until she had one implanted. And the reason, when I say she had one implanted, what happens is that you don't have a choice. So you're having a cardiac incident, and they shoot you off to Rochester or Syracuse or wherever they have a cardiac trauma center, and they say, yeah, you're getting a pacemaker. And you're like, oh, okay. Just let me know when it's done. And they don't really give you a lot of information about it either, so, which is why she got involved, and other people are slowly getting involved in investigating these devices. Patients are physically active, they're holding key roles at work, so it's just something to keep in mind. And it's not really a lifestyle choice, as you know. Okay, so that's a lot of background material, and I think it's kind of important because the more I talk to people, the more I realize that even though I've been looking at this stuff for a couple of years now, and I'm kind of familiar with it, most people aren't. They don't really know what's involved, or who's involved, or how these things work. So in the next group of slides, I'm going to get into the nitty-gritty. I'm going to cover some research by Daniel Halperin of the University of Washington, and he really did the groundbreaking research that I'm aware of. And he actually had a multifunctional team together. So he had a cardiologist, he had electrical engineers, he had computer scientists, and he brought them together for this big project, which I'll go into. The investigation was published in the Proceedings of the IEEE, and it's called Pacemakers and Implantable Cardiac Defibrillators, Software Radio Attacks, and Zero Power Defenses. I find this fascinating. If you do too, ask me about it, and I'll send you a link to the article. It's really great. So what do you need? You need really three things. So you need test equipment, you need a medical device, of course, and a bag of meat. Bag of meat is optional. I'll get into that, why, in a minute. It's not for what you think, but it is kind of related to that. The equipment selection is really going to depend on the communication capabilities of the device and what the device's purpose is. The model, the manufacturer, and some other variables. So we're just going to cover generally what's going on. Let's talk about communication capabilities. So I mentioned the base station earlier, so the device is gonna connect to a base station, so you have to think about the base station. So it's not just the device, it's the device and is it a phone or is it a base station? The frequencies and protocols are gonna vary. So there are 4 common wireless frequencies. There, of course, is Bluetooth, which is the most common today. So anything in the past few years that I'm aware of, anything in the past few years that has been manufactured uses Bluetooth. But you may encounter older devices or devices that have backwards compatibility. So there's a 900 megahertz band. There's a 402 to 405 megahertz medical implants communication band. And then reaching back to the way in the bad old days, there's a I didn't just laser anybody, did I? Okay, good. Let me put that down. There's a 175 kilohertz band. So the older you get, the shorter range and the older the protocol that's being used. The original reader, the original way that you communicate with these devices was actually through a wand, which it kind of looks like this. And the wand has the 700 Gauss magnet in it, just like an earth magnet, and you place it over the device, and that would key the device to communicate. And as far as I know, most devices work the same way. Something to keep in mind when you're doing your hacking. So how did I find this out? Well, it turns out the FCC actually makes this information available to the public for a lot of these devices. The radio frequencies that are used, the device manuals, and some other information can actually be obtained from online sources such as the manufacturer. So because these devices are approved by the federal government, they have to make a lot of the information available anyway. It's just really hard to find. Taking off, Jeff? All right, man.
See you soon. Thank you.
Thank you. All right, Jeff gave up. Jeff quit. All right. Hardware choices. Okay, so now we got to dig into the patient's smartphone, the base unit, the medical device itself. Here's where the red team is going to get really confused. So they have a choice based on the device's capabilities. There are some models that are Bluetooth capable, and communicate with the smartphone. Some are designed to communicate with a base unit. There have been proof of concept attacks that have gone after all 3 combinations and have been able to exfiltrate data, download malicious code to the device, and execute commands on the medical device. But however, since we're thinking about the pacemaker, I'll just focus on that. So here's what you need. Here you go, on the presentation. You can leave now, it's good. Yeah, this is what you need. So what is this, Todd? Okay, so this is an oscilloscope. This actually is a high sampling rate oscilloscope. This one is, what is this? 4 gigasamples per second. Every time I say that, I think I'm walking on the bridge of the Enterprise. So, 4 gigabyte per second, tachyon pulse. Free this up. Get us free of the nebula. What is this thing? This is another antenna. Anybody who's ever built a radio at home can recognize this. What this is. This is an antenna. Basically, it's wire around a core. Any guesses? That's a pacemaker. Yep, there it is right there. Okay. There's the leads off the oscilloscope. This is the receiving. No, I'm sorry. That's the receiving antenna. This is the transmitting antenna. And this right here is a really early software-defined radio unit. So, 2008 technology. Listening antenna, cover everything. Oh, right, yeah, so you gotta write some code. So there's signal processing code. They actually wrote code in C++ and Python, and they used GNU Radio on a Linux machine to actually do the signal processing. So again, that's why you need a cardiologist, an electrical engineer, a computer scientist, various other folks involved. They used MATLAB and Perl for the signal analysis. And there's also all of the other kind of fiddly bits that go around with having an electronics lab. So there's wire, soldering irons, connectors, dongles, anything you possibly want. So about the device itself. Now, this was the interesting part because I want to do research into this. And I was thinking, where the heck am I going to find one of these things? And I went to SUNY, and I was talking to folks at SUNY, and they were like, oh, I don't know, maybe you got to go to the manufacturer. And I thought, well, I'm going to have to call the manufacturer. It's going to be a really awkward conversation. Like, hi, my name is Todd, and I want to experiment on medical devices. Maybe I'll have my wife call. She has a nicer voice. Almost as deep, but not as resonant. So, hey, don't judge. Come on. I was both relieved and a little concerned to find the devices on eBay. So I did not mock this up.
How were they procured?
I went to eBay and I searched for medical lab equipment, patient. I think I put in like Pacemaker. So I put in Pacemaker and I got this. I actually got a lot of these different types of devices. So I don't know the age of this. I think I don't know what vintage it is. You'll see that unit looked to be never used, very clean as new, so that's good. I'm sure when they took it out of the body, it was probably cold. At that point, they didn't rip it out of a living being. The nice thing about eBay, of course, is you can get a 1-year production plan from Square Trade. So very reasonable, $224.95. There you go. I mean, you've got a device, What's it missing? Well, you don't have I think you've got the head. You don't have any leads. You could probably find those somewhere else on eBay. I don't think Amazon is really breaking into this market yet, but I'm sure we'll find some kind of Amazon branded stuff. A little disturbing, but yeah, I mean, it's maybe not used, but still clean medical equipment, and you can use it for your experiments. So wait, okay. So I got the device, I got the oscilloscope, what am I forgetting? Oh, right, the bag of meat, okay. So you can go with different types of meat. There's ground beef, you could do bacon. Now, Halperin actually used, for some reason, ground beef and bacon. Don't know why, but they did. It is optional. So in seriousness, though, what Daniel Halperin's team was doing when they were doing this testing was, first they wanted to find out if they could hack the device, and second, they could figure, is there a way to alert the patient that the device is being hacked? And I think if we were going to continue that line of investigation, that would be really interesting. They actually created an RF receiver that did not rely on battery power. So when it received RF energy, it would activate and it would either vibrate or give off a tone that would warn the user. And they were able to successfully test this. They implanted the device in a bag of meat and tried it out. So now the fun part. So how do they actually go about doing this? This was the hard part. So remember, this is 2008, so they're not working with Bluetooth. They're using I think they went, I can't remember now, but I think it was the 402 megahertz band. So they knew from the cardiologist how because they had a head, they had the programming head with the magnet in it. So they knew how to activate the unit and to get the unit transmitting. And so they just listened on the frequencies. They drew out some other related research into cracking commercial wireless protocols to try to crack the protocol here. So what they actually had to do is they had to, first they had to trigger the device, they had to get the device talking, and then they monitored it. So this top piece is, no, I'm sorry, this is the bottom piece. So they broke the signal down, and they decoded the signal bit by bit. And the thing that they figured out was on the programming head, the lead for the programming head would provided data in the clear, so it wasn't encoded. So they were able to give commands through the programming head, and they knew what those commands looked like when they sent them through the programmer, and then they looked at the response. So the first thing that they actually did was they knew from the cardiologist and the documentation that they could change the patient's name on the device. So that's what they did. They put in a false name, try to see what it looked like. Joe's nodding his head, yeah. So that's what they were doing. Good stuff. So they went after the programmer first, I mentioned that, because the serial connection was in the clear. They modified the name of the patient. Then they used the raw bits in comparison to the encoded and modulated wireless signals to figure out what was going on. From there, they moved on to the more complex task of actually decoding the wireless transmissions. So they didn't get full access to the device, but they got enough access to change information on the device. And I'll go into what they actually changed in a moment. So in case you're wondering, I found an excellent book that describes this very process that they went through. And you can actually get it on Amazon. This is it right here. I think this is core reading for any hacker. or anybody really. I'm trying to get my son into this kind of thing. So what do? So they disclose data. So they got health data from the patient. They were able to decode the therapy regimen. They were able to change how the device responds to the patient, get information about the patient and the doctor. You have to remember that these PMDs, I didn't know this, but PMDs contain a lot of information about the doctor, the patient, the therapy. So when they are in an emergency situation, you go to an ambulance or to an ER, they can decode this information and know what's going on, know what the patient's issues are, know what the device is, and be able to deal with that. I'll get 2 questions then. I'm almost done. Yeah, so we do questions. I know it seems like I'm going to keep talking forever and ever, but I'm almost done. We're getting close to the end. Some devices that were examined by researchers contain and will transmit in clear text the following information: the patient's date of birth, a medical ID number, the name and phone number of the treating physician, the dates of the ICD and lead implantation, the implantable cardio defibrillators in ICD, which can differ, the model, the serial number of the ICD, the types of leads, and other information. And until recently, this information has not been encrypted on the device. Very slowly, these manufacturers are beginning to realize that privacy and security are an issue, so they're trying to put in some safeguards. The problem with the safeguards is, of course, what happens when there's an emergency situation and you have to work with the patient. And that's a whole other ballgame, and I've seen presentations and papers on that. In terms of logging and forensics on the device, they found that audit logs, and protection for the other log information collected by the device was not protected. So they were able to actually go in and modify device logs. Although recently, of course, manufacturers are beginning to encrypt the logs. So Medtronic has released a line of devices that have encrypted logs in them. In terms of forensics, there really isn't, as far as I know, as of 2018, there is not an established procedure for forensically investigating these devices like there is with a computer or a mobile device. Part of the reason, of course, being that the device is attached to a human being. But some researchers have suggested and tried out in the laboratory forensic procedures that can be followed. So that's something else you could do in terms of hacking, thinking about how would you investigate these things in a forensic situation. Okay, so in terms of access, there really isn't a lot of information available. Maintenance procedures for these devices, you have to remember they're really developed during the 60s, so they're developed in a time when we didn't have the problems that we have today. So the patient had a device implanted in a surgical environment, and then the basic programming was done. Shortly afterwards, the patient was taken to a clinic, and then additional programming was done. Actually, my brother used to do this for a living, and he would be involved in testing the pacemaker. So what happens is they put a patient up on a treadmill, and they have the patient go through different levels of physical activity. And the doctor and the sales rep are monitoring the response of the device. So there's one story where my brother and the doctor were talking, and they're huge Bills fans, and we're talking about, I think the Bills were doing well that year, and they're talking about, oh, we could finally get to the Super Bowl, and in the background, the patient's chugging away, and just literally, bam, hits the ground. And because his defibrillator kicked in. And the doctor turns to my brother and goes, oh, I guess I set that a little low. So I think I should adjust that. So that's an extreme example. I didn't tell you that story, but that's kind of the environment that these things were developed in. So wireless came later on, and like everything else, we're just catching up. We're playing catch up on this. So with security and other procedures. Authentication really hasn't kept up. This is really interesting. So Scott Urban, who's another researcher, and he was looking at it from the Bluetooth perspective. He found some defibrillator vendors that use a Bluetooth stack for writing configurations and for doing test shocks, that kind of thing where you're testing out the ability of the device to interact with the patient. And he found that these devices have really default or weak passwords, the kind of thing that you would find on a phone, like a 4-digit PIN. And often those PINs are device or manufacturer specific. So There are a lot of known vulnerabilities that you can look at. You can research some CVEs in this area as well. So it's not difficult to gain access to these things. So TLDR, what can you do? You hacked a device. What can you do? You can set the device clock. So of course that means you can manipulate the event log. You can change treatment, or what's called therapies, which is how the device responds to the patient. So you can either have it react aggressively, or you can actually have it not react at all. So the patient can have a cardiac event, and the device simply just doesn't respond to that. A denial of service attack. Think of it this way. You can put the device into a diagnostic mode, where it continually attempts to contact the base unit or runs diagnostics, and then it just wears the battery down and forces the patient to go in and have additional surgery. You can do some really mean things. So you can introduce VFib, or ventricular fibrillation. So usually your heart is pumping along, just like this. So when it goes into VFib, it stops pumping and it just jiggles. And you hit the floor and you go into cardiac arrest and you pass out, and the next thing you know, you're dead. So this is something that you can do with these devices if you take control of them. The good thing to remember is that the range of communication for these devices is very limited. So at the longest, it's going to be some kind of Bluetooth range. And on and on and on. So you can have a lot of aspects of these devices that need to be investigated. Yeah, I sound really dire right now, but you just have to keep in mind that there are no known attacks in the wild. These devices are safe, they're medically necessary, and they work. They work. They help enable people to have normal lives, like my friend. So this fellow right here is a researcher who's done a lot of additional research since 2008. Other researchers have done attacks against insulin pumps. There have been further research into cardiac devices. This is Barnaby Jack. So he's a very handsome guy. I wish I looked like this guy. He kind of looks like Chris, actually. Chris is like that. There you are. I'm going to say this is Chris from now on, Barnaby Jack. So what Barnaby Jack did was what I just talked about with Halpern's research. He replicated our research, and he actually went farther along. So if you want to dig into this a bit more, look up Barnaby Jack. He has some videos at Black Hat that you can look at. And again, there's further research into researching the forensic procedures for these devices. So. I've lost contact. It always happens on the last slide, too. Yeah. So just to wrap up, the trend in the use of devices, all these devices, just points to more and more usage among a broader spectrum of patients. So going beyond pacemakers, there are devices such as implantable devices for treatment of tremors and Parkinson's disease. They've been on the market for a few years, becoming more and more common. You can think about all of the side effects you have with anti-seizure or anti-tremor medication. You can have a device in your head, and you don't have the side effects anymore. Insulin pumps have really come a long way. There's actually an artificial pancreas that was developed last year. So it continuously monitors a patient's glucose level, and it dispenses insulin. The patient doesn't even have to think about it. So if they maintain a healthy lifestyle, they really don't have to think about monitoring their glucose level throughout the day, and they can go out and be with their families and just lead a normal life. These are really empowering technologies. Down a few years from now, maybe even a year or two from now, if you think about veterans coming back from wars, or people who have had catastrophic injury, the very biomechanical devices that replace limbs, they also have sensors, computing power in them. They might have, maybe they're transmitting, saving data, and transmitting that data to the caregiver to allow them to tweak the device, or there could be other pieces involved, such as gyroscopic stabilization or motor control, things like that, especially if you have an artificial hand. So these things are coming down the line. Prosthetic limbs are going to be big, and another source of potential things and vulnerabilities for people. The good news is that the FDA and other folks in the government are aware of these things. They know that they're vulnerable. There have been additional guidance has been published. In fact, last August, NYSTEC came out with guidance for security issues regarding insulin pumps, which is a great read. So I recommend it. You know, don't watch Punisher. Just get that and read it. It is good stuff. Ripping. So there's good news on the horizon, and of course there's lots of opportunities legally for hackers like us to get these devices in our hands and to investigate them and to help advance safety for patients everywhere. So that went about 20 minutes longer than I expected, because when I did this last time it was 30 minutes, and I apologize. Any questions? Any other questions? No. All right, Chris, you were first.
I have 3 questions. The first
Yeah.
one's kind of
No, I'm sorry, one question.
innocuous. There's hospital branding on the pacemaker. Is that integral to its function, or going inside the body?
Oh, you saw the slide with St. Jude?
Yeah, so
Yes.
is it like when that person dies, they can pull it out and be like, you see, we kept them along this line.
No, actually, it's a good question. No, it doesn't work that way. So St. Jude is one of the, they're a manufacturer, but they're also one of the biggest researchers in the field. So no, it's not, it's a branding specific to them. So the other brands are
they
Medtronic.
manufacture
And,
too. Okay,
yeah,
that makes more
so
sense.
Medtronic is another manufacturer. So
Check.
that's a good, cool. Paying attention. All right. Joe, you want to go?
Have you done research on attacks at distance? You know, how far away you could access the information or interact with the devices?
Yeah, Barnaby Jack has, and he's pushed the envelope a bit, especially since he's working with Bluetooth, as I recall. The 900 megahertz band has some range to it too, if you remember, like the old school phones. So those were 900 megahertz. So, you know, it's within this room basically. That's another thing. Actually, that's a really good limitation of that. Physical limitation is you have to be in fairly close proximity to read or transmit to the device. So it's good to know. I'm sorry, this gentleman right here.
What are the physical security controls around the devices at the hospitals that are designed to interact with these things? Are they typically in a secure environment? Or semi-secure environment?
To the best of my knowledge, the devices are not generally stored at the hospital. They don't maintain an inventory. So there is when a device is needed, there's a sales rep that brings the device to the hospital, goes right into the operating room, and the device is implanted into the patient. So I've asked around, I mean, just unofficially I've asked around to some hospitals, and they agree with that. They don't generally keep devices around in the hospital.
So the physical security controls is sales guy's drunk?
Yeah, basically, yeah. However the sales guy transports it. So it's a good question. Yeah.
Physical security, you have to be close enough with a magnet or a device to get it to actually start communicating. So you'd have to actually come close enough to the heart within, I think it's within 4 to 6 inches to be able to get it into. Might be different, but. And then the other thing is to communicate to the home device, it has to be within 100 feet, which is Bluetooth, a Bluetooth range. And lastly, with a pacemaker, if you want to play around with one, yeah, they're up on eBay. As you mentioned, I just was sitting here looking through going, whoa, there's a bunch of them for under $300 that are available. But if you know somebody that has one, don't play with them, because the pacemaker takes over for the natural beating of the heart. They have to oblate the heart, which means they go in and zap it to shut it off. So the heart is actually running off of the pacemaker. So if you play with the friends, you may kill them accidentally.
That is great. I can't stress that enough. So it even, like my friend who has a pacemaker, I have some devices that allow me to sniff Bluetooth. And just for a moment, I thought, because I was talking to him, and he says, you know, I wonder if you could see my device. It's like, what the heck am I doing? You know? No. No, we're not going down that road, buddy, because I don't know what's going to happen. That is great. Yes, being responsible is so important. I just want to mention, yeah, actually, all of the devices can be activated by a magnet. Barnaby Jack, check out his research. He actually is the guy who really has gone down the road of the wireless interfaces. I think he's the one who's shown that in some cases they will respond to wireless signals. So.
And the home, one other thing, the home-based unit for people who do have a pacemaker is either cell phone technology or dial-up phone line technology. As far as I know, they don't have anyone that's hooked up directly to a network that I know of. But that could change tomorrow.
Yeah, I haven't heard of that either, so I don't think there's any direct network connections, dial-up or wireless. So, Chris.
Did you stumble across any researchers that had any mishaps with working on live people?
No, because they're not. Generally, they're not working on live people.
Okay, well,
It would just be unethical to do so.
Sure,
So,
sure.
Yeah, but.
Well, yeah.
But you know, it's like okay. So Maria Mo has a pacemaker, and she's working on a pacemaker.
On her own, though?
Not on her own,
Oh.
but she has a device. She
Yeah.
actually lives in Europe, I believe, so they have different laws, and I think it's a bit easier for her to get into it. But yeah, I mean that is a concern. So I didn't really delve into that too much myself, but I'm sure she takes a lot of precautions. So, Chris again.
Has anyone held these?
I'll take random questions for Todd for 500, please.
These manufacturers, right? So like they pump these devices out, like you said, talking with no encryption. They're divulging.
Until recently, I know encryption.
Yeah, and so they're divulging loads of information about the patient. Is anybody holding these companies responsible for not giving a shit up until now when they're being told they have to give a shit?
Okay, so actually, if you buy my book, Chris, you come to my other presentations. This is where my colleague Michelle Warner, who's the privacy attorney, will grab the mic from me and start. Yes, there are regulations that do put responsibility and liability on the device manufacturers for issues. There is, if you want some fun reading, look up Rigel v. Medtronic, which is a key Supreme Court case that actually limits liability of manufacturers in the case of a device malfunction. So what they term a malfunction. So it basically makes it really hard to prove that the device manufacturer is at fault if something goes wrong. So.
It's terrible.
Yeah, I mean, there's a lot of, I mean, Michelle can go into it more about the legal reasoning. So I think it just really has to do with the fact that it's a medical device and there are known risks. And even though it's something that you need to maintain your life, you assume more risk because you are using the device kind of thing.
And so it's skate because attribution is challenging?
Perhaps. Yeah, I don't know. But you got to remember there really haven't been any known attacks in the wild on these devices, so it may
So that's
change.
yet to come.
Yeah.
That we know of.
That we know of, yeah. But I think actually these researchers, and these are folks just like us, they're publishing their findings in medical journals, they're working with doctors, and I think that's putting a lot of pressure on device manufacturers. And that's why we're seeing like Medtronic has begun to encrypt devices now. So it's also getting more and more of the public consciousness that these things need privacy. Yes, sir.
One last thing that I have to bring up. If you're interested in playing with medical devices, and if you go out to DEF CON each year, they now have for the last 2 years, I think, a medical device hacking village. So you can spend hours in there playing around and trying to hack anything from insulin pumps to pacemakers to anything that's connected to anything IoT related for the medical industry. So that's one thing to keep in mind if you go out to DEF CON.
Chris, you going to DEF CON?
Last one. What was the strangest PMD you came across?
The strangest PMD I came across? I think we're in mixed company. I can't really talk about that. No, like define strange. Help me out here.
Who makes your sweater vest?
Todd's wearing a sweater vest from Target.
Personal medical device that.
Okay, so this is what I.
Kind of outside the realm of the normal plan.
No, really. I mean, I mean, there's glucose monitoring devices, CGMs, that actually work off of your skin chemistry. So usually in my other talk, I get even more gross, and I have diagrams about where the needles go and things like that. So what they're trying to avoid with diabetics is pricking them with needles all the time. So they're looking at like your skin chemistry, so your sweat, and trying to determine blood chemistry off of that. And that's something I'm thinking that is actually going to be used in another way for athletes. So they can monitor their blood chemistry live, and as they're working out, and help to increase their athletic performance. I bet within 5 years, you're going to start seeing CGMs that are modified to do that. Epilepsy monitors. A friend of mine has a child who has a seizure disorder, and they're looking at getting her an epilepsy monitor. It looks like a smartwatch. It's a very fashionable item, you know. And it will, if it detects a seizure, especially if it's a grand mal seizure or something like that, it'll call a caregiver. It also calls for 911. So when the ambulance shows up and you come out of your seizure, you'll have medical help, but you'll also have someone there who's a familiar face. So, it's amazing. I think the weirdest things I've seen, weird in a way, are I wasn't expecting the prosthetics to have these same capabilities, but especially the artificial hands that they're developing, because they require such dexterity. Just the amount of computing power is stunning. So, yeah. The implantable cardiac brain devices are really interesting too. So, they've been out of the market for a couple years now. So. People are reporting some strange side effects. So some folks are reporting a sense that there's someone in their head or another presence nearby when the device is active. So it's just kind of odd things like that. So I get a lot of stories. It's fun. Okay, is that it? Can I let you go? Thank you very much. It's not often you get to indulge in a pet project like this. So thank you. Really appreciate it.
Yeah, thanks, Todd. Let's make some more noise for Todd. That was an awesome talk. All right, so I got a quick announcement. So, let me just make sure it's right. Do you all know that you have a global standards organization right in your backyard? Anyone know this? That's right, you gotta come to the next IBEER, February 20th, to find out.
I'm just learning marketing. All right.
Yeah. I like that one, dude.
Thanks, Todd.
All right. Thank you.
I was thinking like maybe
Coming soon to a live